Okay, so now I am recording, yeah? I'm recording. So let me check for a while. Okay, everything is recording smoothly, yeah? Okay, very nice. So, okay, now we will explain about string, yeah? Formation of standing wave in string, yeah? So, I've explained a little bit about the fundamental mode for string, okay? Now, first of all, this formula. Speed of wave on a stretched string, yeah? V is equal to square root tension over mu. T is tension in the string. And then mu is the mass per unit length of string. So I also have already explained about this. Yeah. Basically, you know, mass per unit length of the string normally is refer to the, we can say, proportional to the thickness of the string lah. Thickness of the string. Yeah. With thicker string we have more mass. Yeah, more mass. And then thinner string has less mass lah. So I also explained about that. Yeah. Okay, I use an animation also, right? So like you see here, you have thin string, thick string. Okay, and then tension, we normally tune the guitar. Yeah, we tune the guitar to apply different tension in the string. So that will result in different speed of wave on the string. Yeah, that will result in the, when you change the tension, you change the thickness of string, you actually will change the speed of wave traveling on the string. You change the speed of wave traveling on the string. Ultimately, it will change the frequency of sound produced by the string. Yeah. Frequency of sound. So for a stretched string, we can set up a standing wave patterns at many frequency. The more loops, the higher the frequency. More loops means shorter wavelength. Yeah, more loops means shorter wavelength. Yeah. So okay. I did have have an animation for this. I've shown yesterday, so I think that's enough. Okay. So this is the one lah. Okay, the mode. To explain this, I think it's better for me. I goes directly to this one. Yeah. Okay. So let me start from here. Yeah, straight away. So let's look at string first. Yeah. Look at string. So just want you to focus on this part first. Okay. Look at the string. Yeah. String. Okay, the first one is called the fundamental mode. Okay, fundamental mode F. Yeah, fundamental mode is called fundamental mode. So fundamental mode, the wave look like this. Yeah. So we know that these two end is a note because they are fixed. Yeah. One point you fret, one point is fixed at one end. So they are note. Note means the particle cannot vibrate at all. Yeah, cannot vibrate at all. So the center has to be anti-note. Okay, anti-note. Alright, so this is a half lambda, L equal to half lambda, and finally frequency we get V over 2L. Okay, V over 2L. So this is fundamental mode. And then going to the next overtone, okay, we plus another half lambda, So now this is how many lambda? Tell me, this is how many lambda? How many lambda, class?
One.
This is considered as one lambda, yeah. Because from from node going to another node is half lambda. So plus another half, you get one lambda lah. So this whole length is one lambda. Okay, one lambda. So and then frequency is V over lambda. So lambda we just substitute with L. Yeah, lambda we substitute with L. Okay, V over L. And then okay, because we want to compare this one to the first one. We want to compare this one to the first one. So we multiply two. Yeah, understand? Actually, it's start from actually is equal to this, isn't it, class? Actually is equal. Yeah, lambda we substitute with L, right? Lambda we substitute L, so we got V over L. And then let's say I want to compare this frequency F2 with the F1. So I make it, I multiply 2. I multiply 2 at the below. Yeah, I multiply 2. So here I multiply 2. And then here at the top also I multiply 2. Understand? If I multiply 2 below, I also must multiply 2 above. Okay. So can you see the similarity between this one? So this part is the same. Yeah, you see this part. This part V over 2L is the same as above. V over 2L. So we substitute V over 2L with F1. Yeah, V over 2L with F1. So now we get what? 2 multiply F1. Okay. So what is how many times is F2 compared to F1? How many times?
2 times.
Yeah. So this frequency is 2 times the fundamental frequency. You see that? This F2 is 2 times the fundamental frequency. So let's say the string this 2 times the fundamental frequency means what? Means the pitch of the sound is twice higher than the fundamental mode. Like, okay, let's say the string is like so this first overtone frequency is twice higher. You understand? Twice higher. And then you go to the second overtone, it becomes understand? It becomes higher and higher frequency. You know why it becomes higher and higher frequency? Because for the same length, it has shorter wavelength. You can see this one is longer wavelength. This one is this one is longer wavelength. This one is shorter wavelength, and this one becomes shorter, even shorter wavelength. Shorter wavelength means higher frequency. Understand? Higher frequency. What I mean is, for the same length of string, 10 cm, this one also 10 cm, this one also 10 cm. Okay, fundamental mode just like this. First overtone is like this. Second overtone is like this. Second overtone is. So which one has longer wavelength, class? Which one has longer wavelength? Of course, this one is longest wavelength, right or not? This one has shortest wavelength because for the same length of string, this one the wavelength is shorter. If shorter, this one is higher frequency. This one is lower frequency. Understand? So actually, this is considered as F1. This is F2 equal twice F1, and then later F3 is 3 times F1. That means this one the sound if produced is 3 times higher. 3 times higher. Frequency, you know, frequency is actually the pitch of sound. Pitch means what? Highness of sound. Yeah, highness of sound. Yeah, ketinggian suara. Ya, ketinggian bunyi. Ketinggian. Ketinggi. Yeah. So if we want to look at the pitch of sound or the highness of sound, we look at frequency. Last time we look at amplitude. Amplitude is called the loudness of sound. Loudness of sound. So it's different. Yeah. Loudness is kekuatan. Kekuatan suara. Kekuatan suara. Ketinggian dan kekuatan sama tak? It's different, right? Yeah, a sound can be very low but very loud. Yeah. So it's different. Yeah. So if frequency is referred to highness of sound, the pitch of sound. So what is frequency? What is frequency? Okay, let me. This one also I have to explain a little bit. Yeah, I have to explain a little bit about frequency and amplitude. Yeah. So I let you see a few wave. I let you see a few wave, and you tell me. Yeah. And well, how to look at amplitude? How to look at frequency? How to look at amplitude? How to look at frequency? Okay. And then this one is understand, class? This is y versus x graph. Okay, x lambda. This one lambda 1, this one lambda 2. And then this is A1, this is A2. This one have the same A. Okay, class. A basic, very simple questions to test your understanding first. Between the difference of highness and loudness. Yeah. So okay. What is this for comparing the first put this as number 1, situation number 1, and this one situation number 2. So they are different a little bit. Yeah, different a little bit. Okay, class. For the first one, this one is what's the difference between these two? What's the difference between these two? Put this as number 1, this one as number 2. So what's the difference between these two? Tell me.
Lambda.
Lambda. Okay. Lambda, good. Lambda is will influence what value?
The pitch of the sound.
Yeah, pitch of the sound. Yeah, lambda means it will change the frequency. So it's like we know that speed of sound is constant. Yeah, speed of sound is constant. Yeah, constant, which is speed of sound in the air is 343 meter per second. Okay, so v equal to f lambda. Okay, v equal to f lambda. So the longer the wavelength, the lower the frequency, isn't it? So we can say this one has the first one, it has the lambda one is longer, so it has higher or lower frequency? Lower frequency. So F1 is lower frequency. So here you can hear low sound. Okay, and then for this one lambda 2. This one lambda 2 is shorter, right? So this one you can hear higher frequency. Higher frequency means what? Very high sound. This one low pitch. This one high pitch. Understand? Yeah. How to demonstrate? Low sound. This one high pitch. See? Understand? No response. That means you don't understand, is it?
Yes, sir.
Yes, at least a little bit lah. So okay. How about the second one? Second one, do you think they have the same pitch? Talking about the lambda, they have the same lambda? Yeah, they have the same lambda. So we can say both have the same pitch. I can say both are the same level of sound. Okay, the same pitch of sound. But what's the difference between these two sounds? What's the difference?
The loudness.
The loudness. Yes. This one, this one, the. Understand? So I put it this way lah, yeah. Or we can put it as let's say, put it at I demonstrate again. This one, the. Do you see the difference? The loudness of sound?
Yes.
So this one is we can say low amplitude. This one high amplitude. Yeah, but the pitch of sound is the same. The pitch of sound is the same because the lambda is the same. Okay. This one is, we can say, it's a soft sound. Soft sound. This one is a loud sound. So that's the meaning of amplitude. That's the meaning of amplitude. It changes the loudness of sound, and that's the meaning of lambda. It changes the frequency of sound. Changes the frequency of sound means it changes the pitch of sound. Low sound, high sound. Yeah. Okay. So that's why, huh? You need to understand everything, the concept. So I can say like this one is long wavelength. This one is short wavelength. Yeah, because for the same length, this one has more loops. This is what it means by, you see, what it means by more loops, the higher frequency. Understand? More loops, the higher the frequency. So this one has more loops, means it has shorter wavelength. Shorter wavelength means a higher frequency. So it's like so the second one is double the first fundamental frequency. The third one is three times the fundamental frequency. Okay, class, understand?
Yes, sir.
Very good.
Yes,
Yeah, very good. So, intensity. Another word for loudness is intensity. Between in pitch, frequency, and intensity. So there's another terms for loudness. Another terms for loudness is intensity. Intensity of sound. Okay. Another word for pitch of sound is frequency of sound. Frequency. Frequency is highness of sound. Intensity is loudness of sound. Intensity. Yeah. Last time I taught before. Last time I taught before in my old video. Yeah. But not as detailed as this lah. I somehow even draw the diagram for you. Yeah. To demonstrate the idea even clearer. Okay. Now, what about this harmonic number? What does it mean by this harmonic number? But first, before I go to harmonic, you must first and then just now why I say the fundamental frequency and then the second the first overtone frequency is 2 times, and then the second overtone is 3 times the fundamental frequency. How do you get these 2 times and 3 times? How do you get these 2 times and 3 times? That's the question. How? That is, you calculate the number of wavelength. That's what I showed to you just now. From here, note to note to note. That means half lambda become 1 lambda. So just now I did demonstrate, explain to you this lambda we substitute with L, and then you multiply 2, and then you compare with the first one. You know, V over 2L we substitute with F1. Yeah, I substitute F1. That's how we get this. How we get this frequency F2 is 2 times the fundamental frequency. Now, do you see it, class? Do you see it?
Yes, sir.
Yeah.
Yes, sir.
That's how we get the 2 times the fundamental frequency. The third, and then this one third. How do we get 3 times? How do you get 3 times? So all mathematics, class, what I will tell you is all are mathematics and some drawing, basic drawing. So as we go down to the next level, we always add half lambda, half lambda. Okay? Half lambda. So we go to the next one, we add another half lambda. So what do we get? So this is half plus half plus half. So we have 3 halves, isn't it? We have 3 halves. So the whole length is 3 half lambda. Can you see the 3 half lambda? This is a half lambda, right? So 3 times half lambda. And then lambda put in front. So 2 multiplied to the top become 2L, and then 3 go below become divide by 3. So lambda equal to 2L over 3. Okay? And then frequency F3 is equal to V over lambda. Yeah, V over lambda. This lambda we substitute with 2L over 3. Substitute with 2L over 3. And then 3 go to the top. 3 go to the top. So the formula become 3V over 2L. 3V over 2L. And can you see that the V over 2L is the V over 2L here, class? Can you see it?
Yes, sir.
The V over 2L here is the same as V over 2L here. So this V over 2L can substitute with F1. And that's why we get this F3 is 3 times the fundamental frequency. 3 times the fundamental frequency. Just now the second one is 2 times the fundamental frequency. The third one is 3 times the fundamental frequency. So it's like third. Okay. Now going to the mode. The first one is always called the fundamental mode. And then going down, it becomes first overtone. And then going down becomes second overtone. And then you can even draw some more. You can put third overtone, fourth overtone, fifth overtone. But you must know how to draw if third overtone means you have 4 loops. You have 4 loops. If fourth overtone, you have 5 loops. If fifth overtone, you get 6 loops. Then the frequency also become 4 times, 5 times, 6 times. Understand? 6 times the fundamental frequency. That's mode. Yeah, you always start with F, then go to the first overtone, second overtone, and third overtone. Same for all closed pipe and open pipe also. Yeah, the first one is always called fundamental mode. And then the next one is first overtone. And then the next one is second overtone. And then the next one is third overtone, fourth overtone, and then fifth overtone. Okay, class?
Yes, sir.
Okay, now go to the harmonic. It's a little bit different. Harmonic, what is harmonic? Harmonic is looking at multiplier of fundamental frequency. That means how many times is each of these overtone, how many times of their frequency higher than the fundamental frequency. Okay, all the fundamental mode is put as first harmonic. Because they are the base frequency. They are the smallest frequency. So they start with first harmonic. And then the next overtone, we always use the first harmonic to compare. Understand? First harmonic frequency to compare. So if the frequency is 2 times, like this one, 2 times the fundamental frequency, then the harmonic number is 2. If the frequency is 3 times the fundamental frequency, then the harmonic number is 3. If the frequency is 4 times the fundamental frequency, then it's 4 harmonic. If the frequency is 5 times the fundamental frequency, then it's 5th harmonic. If the frequency is 6 times the fundamental frequency, then it's 6th harmonic. Class, do you see? Do you see, class?
Yes, sir.
Yes, sir.
So what is harmonic? Class, you tell me what is harmonic number? What does it mean by harmonic number? What does it mean by harmonic number?
Multiply fundamental frequency.
That means how many times each frequency higher than fundamental frequency. So if the first overtone is two times higher than fundamental frequency, and for second overtone is 3 times higher than the fundamental frequency. Understand? So it's multiplier of fundamental frequency. So harmonic number is represented by the symbol n. Represented by the symbol n. N is harmonic number. Yeah? N is how many times the fundamental frequency. Understand? So like you see, why I put this as F1? Why do I put this as F1 instead of F0 or what? Why I put this as F1? Class, you tell me why I put as F1? Because 1 is the harmonic number. Understand? 1 is the harmonic number. So the second one, why do I put as F2? Why do I put as F2? Because 2 is the harmonic number again. Understand? 2 is the harmonic number. Why do I put this as F3? Because 3 is the harmonic number. And then for fourth harmonic is F4, F5, F6. So, now, I want you to see one thing. Yeah? I want you to see one thing. So we have a general formula for the string. The general formula for string is F. Just now F3, yeah, we have F1, F2, F3. So this 1, 2, 3, what is it? This number, why is number 1, 2, 3? What is it represented?
Harmonic number.
1, 2, 3 is the harmonic number. So we can put as Fn. Understand? N. N is the what? And what is N? What is N?
Harmonic number.
Harmonic number. Harmonic number. So N is the harmonic number. Okay, and then equal to, for string, the general formula, one general formula to represent all condition is NV over 2L. NV over 2L. Do you see? Why is it NV over 2L? N, what is N? N is the harmonic number. How many times the fundamental frequency, how many times the frequency higher than the fundamental frequency. Okay, so N. So N is all this number lah, like the 3 here, like the 2 here. Class, do you see? Here we have, again, here we have 1V, F1 is 1V over 2L. F2 is 2V over 2L. F3 is 3V over 2L. Again, F1 is 1V over 2L. F2 is 2V over 2L. F3 is 3V over 2L. So Fn equal to NV over 2L. Class, you understand? I'm shouting already.
Yes, sir. Yes.
Yes, sir.
I'm shouting already. Hopefully, until I explain until I'm shouting, that means you should understand already lah. Okay. Okay. So NV over 2L. Yeah, NV over 2L. So N is the harmonic number. So N can be start from 1. 1 is the fundamental mode. Yeah, and then it go 1, 2, 3, 4, 5, 6, and so on. Yeah. So N can be start from 1, 2, 3, 4, 5, 6, and so on. And then we also can put it as Fn equal to NF1. That means if F1, let's see, F2 is 2F1. F3 is 3F1. Correct or not? So that's why we put Fn equal to NF1. If F6 is 6F1. Let's say the fifth overtone, which is 6 harmonic. 6 harmonic. So is F6. Fifth overtone is using F6. equal to 6F1. 6 times the fundamental frequency. Understand, class?
Yes, sir.
You know, shouting like this, it's like, it's almost similar to those, now the people who go for, who, manifesto, now voting, people are shouting also, almost similar to that kind of emotion lah. You see, if you listen to them speaking their manifesto right now, almost like that, because this is the voting season, okay. So now, class, I want you to see one thing here. V, just now we learned the V here, speed of the frequency. This is the general formula to represent all condition, to summarize everything. So you can you see the formula is F equal to NV over 2L. So the frequency of sound that were produced by the string is closely related to speed of wave traveling in the string. Frequency is related to the speed. Do you see that? And then we learn about the speed of wave on the string, isn't it? So just now the formula, frequency is NV over 2L. This frequency is influenced by, or we can say depend on the speed of wave on the string, which is dependent on this formula. So if the velocity increase, speed of wave on string increase, the frequency also will increase. Understand? So that means if you change the tension, you increase the tension, that will increase the velocity. You increase the velocity, the frequency of sound produced by the string also increase. That's why you tune your guitar. If you tune it tighter, if you increase the tension, you increase the speed of wave in the string, increase the speed, the frequency of sound also will increase if you tighten the string of guitar. Do you remember you tune your guitar, class? Those who never play guitar before, they don't know lah. Maybe you need to play the guitar only, you know, about tuning the guitar. You know, if you don't tune your guitar for a long time, the tension become, the tension of guitar, where's my guitar? My guitar is an animation guitar lah. Tuning the guitar, you are tuning, you are rotating this. This what we call this tuning lah. I just know about tuning. You actually, when you turn this knob, you actually tighten, you increase the tension in the string, isn't it, class? You increase the tension in the string. So that will increase the speed. You increase the speed, you increase the frequency of sound. So that means if you tighten the string, the sound, the frequency of sound increase. Become higher sound. Correct or not, class?
Yes, sir.
Hopefully you understand. I sweat and toil telling you all this. So okay, this n number is called harmonic number lah. So in short, I can say this harmonic. We have first harmonic, second harmonic, third harmonic, fourth harmonic, and so on, right? So it's called all harmonic. I got all harmonic number. See, because it got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So got all harmonic number, right? Got all harmonic number. So we say string is all harmonic. It got 1, 2, 3, 4, 5. There are some example like close pipe. It doesn't have all multiplier of frequency. Like the fundamental mode is first harmonic, but then the first overtone become third harmonic. It's not second harmonic. It jump to third harmonic, and then it jumps some more to fifth harmonic, seventh harmonic, ninth harmonic. So what is this number? Is this odd or even number?
Odd number.
Odd number. So we call this odd harmonic. Odd harmonic. Yeah, this one is all harmonic because it got all multiplier of fundamental frequency. That means it got 2 times frequency, got 3 times frequency. But this one, no, this one is 3 times frequency, 5 times frequency, 7 times frequency, 9 frequency. Why is it like that for closed pipe? So closed pipe, now we go to closed pipe. Okay, closed pipe. For open pipe, is actually similar to string, yeah? Open pipe is similar to string. Now we go look at closed pipe first, yeah? Closed pipe. Good. So yesterday, I already explained how to look at you know, this node and antinode, the distance between them, yeah? So node to antinode is 1/4 lambda, right or not? And this is node because it's a closed end, and this is antinode because it is open end. So the particle can vibrate freely. Okay. Now, this is 1/4 lambda. So L is the length of pipe. Length of pipe is 1/4 lambda. So what is 1 lambda? Lambda is 4L lah. Okay, lambda equal to 4L, and then we apply to the frequency, the formula of V equal to F lambda. So F equal to V over lambda. So this lambda we substitute with what? We substitute with 4L. We substitute with 4L. So, okay. So we put this V over 4L as F1. Okay? F1. F1 because fundamental mode, yeah? First harmonic. F1. Now, going to the next one is somebody please mute your microphone first, yeah? Somebody please mute your microphone first because you opened your microphone accidentally. Okay, everyone mute your microphone. Everyone mute your microphone. So when asked to respond, you respond. Okay. Class, look at the second one. Second one is we plus another half lambda, isn't it? We plus another half lambda, and then the next one also plus another half lambda. Okay, so for the second one, we put a half lambda. I put a half lambda there. So half plus 1/4 lambda lah. This is half lambda plus 1/4 lambda. So half lambda plus 1/4 lambda equal to how many lambda? 3/4 lambda. Correct or not, class?
Yes, sir.
Half lambda plus 1/4. So half become 2/4 kan? Half become 2/4. 2/4 plus 1/4 become 3/4. Correct or not?
Yes, sir. Yes, sir.
Yeah, 3/4 lambda. So this L is equal to 3/4 lambda. So lambda is 4L over 3. 4L over 3. So now this lambda we substitute with what? We substitute with 4L over 3. Okay. So the formula rearranged become 3V over 4L. Yeah. This lambda we substitute with 4L over 3. And then the formula will become 3V over 4L. So now can you see that this V over 4L is the same as this V over 4L? Can see, it's the same, right? So how many times is this frequency compared to fundamental frequency? How many times? Class, can you see? This F3 is V over lambda, isn't it? So lambda we substitute with what? Lambda we substitute with 4L over 3. Correct or not? And then we multiply 3. So gone already. So we got what? We got 3V over 4L. Correct or not, class?
Yes.
3V over 4L. Which is this lah? Which is this? So this and then this V here you can see V over 4L kan? This V over 4L is represented by F1. Do you see that? It is F1. So F1, so it become 3F1. F3 is 3F1. 3F1 means what? Class, what does it mean by 3F1? What does it mean by
High
3F?
frequency.
Yeah? That means this first overtone is 3 times the frequency of fundamental frequency. Understand? This first overtone is 3 times the fundamental frequency. So 3 times higher. Like this one is third. This one third already. It's not even third. It's straight away jump to third. Okay? 3 times the frequency. This one 5 times the fundamental frequency. That means it's third. Yeah, I can't even make that sound. Yeah, it becomes sound like a duck. You understand? Like itik. Okay. So this is 3 times the fundamental frequency. Okay. So here we put as what? F. Not even F2. We put as F3. Why do we put F3? Because that's the harmonic number, right? Harmonic number refer to the multiplier of fundamental frequency. So since the frequency is 3 times the fundamental frequency, I need to put as F3, not F2. Put as F3. So this one is 3F1 because it's 3 times the fundamental frequency. And then go to the next one. Is half lambda plus half lambda plus 1/4 lambda. So half plus 1/4 equal to how many lambda? Or we can say half plus half equal to 1 lambda kan? 1 lambda plus quarter lambda. Berapa lambda?
5, 4.
144. 4 plus 1, 5 lah. 5 lambda over 4. Correct or not? So this L equal to 5 lambda over 4. So lambda is 4L over 5. 4L over 5. Okay? 4L over 5. And then what else? What else? 4L over 5. And then we substitute again. 4L over 5. We substitute to the lambda here. And then finally we get 5V over 4L. 5V over 4L. So V over 4L is again same as F1. So we substitute V over 4L with F1. So we get 5F1. What does it mean by 5F1? What does it mean by 5F1? That means the second overtone frequency is 5 times the fundamental frequency. 5 times the fundamental frequency. So 5 times higher. You know, the sound is 5 times higher. How about we go to the next one, the third overtone. We go to the third overtone, it surely go to the 7th harmonic. 7th harmonic means 7 times the fundamental frequency. We go to the 4th overtone. Then 4th overtone become 9 harmonic. 9 times the fundamental frequency. Okay, class, I want you to see one thing, very basic things here. When looking at the mode, it always follow the sequence. Fundamental mode, always start with fundamental mode. And then go to the first overtone, go to the second overtone, go to the third overtone, go to the fourth overtone. For mode, no problem. But for harmonic number, can you see the difference? Harmonic number is the multiplier of fundamental frequency. It depends on how many times the fundamental frequency. It doesn't follow order. Like this one, you see, doesn't follow the order. It follow the harmonic number is multiplier of fundamental frequency. You need to look at how many times the fundamental frequency. So in order to look at harmonic number, you need to look at the shape of the graph first. You need to derive yourself. Derive yourselves how many lambda is this, and then substitute and then compare with the fundamental frequency. Then only can see the harmonic number. Understand not, class?
Yes, sir.
Good. Okay, go to the next one. Open pipe. Open pipe is what? Open pipe is open at both ends. Just now is closed pipe open at one end only. Yeah, that's why got only one antinode. But open pipe got open at both ends. Both end open. So it's antinode also antinode. Because both end open. So both end can rotate freely. Can oscillate freely. So can vibrate freely. So both end become antinode. So okay, class, we learned before, antinode to antinode, how far? How far is antinode to antinode?
1.
Half lambda. Antinote to antinote is the same as note to note, isn't it?
Yes.
So this is half lambda. This one also half lambda lah. Understand?
Yeah.
Yes, sir.
So do you see for open pipe and string, cuma close pipe saja yang odd, very odd. But for open pipe and string, same, everything same. And so actually, because this is antinote to antinote, this one also note to note. And then go down is you plus a half lambda. This one also plus half lambda. So the difference is the same. You see that? This one is antinote to antinote half lambda. Plus another half lambda become 1 lambda lah. This one also half lambda. You plus another half lambda. You plus another half lambda. Also become 1 lambda. So it become the same. You see that? It's the same thing, isn't it? Can you compare this string and open pipe? It's the same thing. You see that? And then this one and this one is the same. You see that? So for open pipe is also known as all harmonic. All harmonic same like string. String is all harmonic. The harmonic number got 1, 2, 3. The open pipe also all harmonic. 1, 2, 3. Fundamental mode is first harmonic. First overtone is second harmonic. First overtone is second harmonic. Second overtone is third harmonic. This one also third harmonic. This one fourth harmonic. This one also fourth harmonic. So for open pipe and string is similar. So what I can say is the general formula also the same between string and open pipe. Fn is equal to Nv over 2L for string. For open pipe also Fn equal to Nv over 2L. Same for open pipe. All harmonic. Understand? But only difference is the speed of sound. Later I will explain about speed of sound. But first I want you to look at closed pipe. Closed pipe is odd lah. Odd. Ya? Odd. Cuma antara tiga ini yang closed pipe saja yang odd. Yang lain itu normal. Boleh kata normal. Dia pun harmonic number itu ada semua number. Cuma closed pipe ini odd saja, ganjil. Ganjil. So harmonic dia lain. So formulanya, general formulanya pun lain. For closed pipe is Nv over 4L. The other two, string and open pipe, both are Nv over 2L, Nv over 2L. For closed pipe is Nv over 4L. This one is 4L. String and open pipe, they are 2L, 2L. Understand? 2L, 2L. But closed pipe is 4L. And then the harmonic number also don't have all the harmonic number. It got all the other got 1, 2, 3, 1, 2, 3, 4, 5. This one only got odd number. 1, 3, 5, 7, 9, and so on. Why is it like that? Look at the formula. Compare the formula. Just now we already derived this formula, kan? See the pattern? I want you to see the pattern only. See the pattern. The first one is F1 equal to 1V over 4L. The second one is F3 equal to 3V over 4L. And then the third one is F5 equal to 5V over 4L. Do you see that? And below is 4L, not 2L. For the others all are 2L kan. But for closed pipe is 4L, 4L, 4L. So the general formula also 4L. And then the number is 1, 3, 5. And then of course, what can we expect for the third overtone? It must be 7. And then what can we expect for fourth overtone? Must be 9. Correct or not, class?
Yes.
Because it's 1, 1, then go to 3, go to 5, and the next one go to 7, and then go to 9, isn't it? It follow the pattern, isn't it? If we draw some more, we draw the wave some more. Elaborate more wave. Yeah, this one got 2 loop. Then the next one got 3 loops plus another quarter. And then the fourth one become what? Got 4 loops plus 1 quarter. So you get is odd harmonic number 1, 3, 5, 7, 9, and so on. But for string and open pipe, we consider them as a normal person. Normal person means they have all the number lah. 1, 2, 3, 4, 5, 6, 7, and very good. This one also 1, 2, 3, 4, 5, 6. All it got all harmonic. It got all harmonic. Only closed pipe is odd harmonic. Only got the odd number. Odd multiplier of fundamental frequency. You got all the odd number of multiplier of fundamental frequency. So it's like that. Yeah. So this string and open pipe both are 2L, 2L. Okay, this one only close pipe is 4L. Okay, class. Last one is this one. Speed of sound. Okay, this one is using string, isn't it? This one is using string. I know the time up. This one is using string. This one is using close pipe. This one open pipe kan. So this one is string. This one is air particle, air particle. So the speed of sound. This one the speed is traveling. The wave is traveling in where? The wave is traveling in the string, isn't it, class? So the speed of wave is using this formula. Refer to the tension of the string. Refer to the mass per unit length of the string. So this speed is dependent on this formula, square root tension over mu. But for closed pipe and open pipe, the wave travel in the air. The wave travel in the air particle. This one also wave travel in the air particle. So for the speed of sound in the closed pipe and open pipe is constant. These two are constant. Constant. You know why constant? Because the speed of sound is travel in the air, not in the string. In the string, it depends on the tension of the string and mass per unit length on the string. But for closed pipe and open pipe, the wave travel in the air. Wave travel in the air is speed of sound in the air, which is this value 343. Sometimes put as 343. Sometimes also we put as 330. Depend on the question. Yeah, so what is the value it give? Then you just follow the value lah. Okay, speed of sound in the air is constant. But for speed of sound in the string is changing lah. Changing depending on the tension and mu. Okay, that's all I want to explain for this part. So the next class I will explain question already. Okay, thank you class. Okay, see you again. Bye.